Hello, I'm Jim Kuiper. I'm professor of computer science and software engineering at Miami University, Oxford, Ohio, and this is part one of testing with equivalence classes. In this tutorial, we'll be talking about kind of a systematic way of testing. But let's start with a simple example. Suppose I ask you to test a method, a function. This method takes one parameter, which is an integer, and produces a string as its output. Now that's all I'm going to tell you right now about this method. If we knew more about the method, we could test more effectively, but let's see what we can do just from that simple amount of information. How would you test this? What inputs would you use? Now, let's first ask, what are all the possible integer inputs you could have for this? Your reaction may be, well, that's an infinite set. In mathematics, yes, it's an infinite set, the set of all integers. On the computer, it really isn't an infinite set. There's only a certain number of integers that can be represented, and that's however, is a huge number, and to try to test each of those would be virtually impossible just from the amount of time it would take. So how would you test? What values would you use? Well, maybe you'd try some small positive integers, 1, 2, 3, maybe 9, 7. How about some large numbers? The question is, could a program fail on large numbers even though it worked on small numbers? What about a negative number, say negative 19? It's been my experience in working with novice programmers that they tend to forget about large numbers, negative numbers, and even 0. All those are values that we ought to test. So if we think of all of the possible things that we can input as our input space, equivalence class testing is a method of dividing that into a set of equivalence classes. In this particular example, you can see I've identified 1, 2, 3, 4 different equivalence classes. The idea here is to break up the input space into several smaller subsets that we call equivalence classes and use those to guide our testing. From each of those equivalence classes, we will select one or at least one piece of test data. The hope here is that if that test data, say this one in the first equivalence class, if that test data identifies a failure in the program, that any other test in that equivalence class would also have failed. Or conversely, if this item that we picked to test from that equivalence class works successfully, then others in that equivalence class would also work successfully. So what equivalence classes do you think we should have here, just given the information I've given you, which is that the program has one integer input and produces a string output? Each of these is called an equivalence class. Can you guess why? I think you may be able to see that each of these is, we call it equivalence class because every element of the set is equivalent to every other element in the set with respect to its ability to identify errors. Or at least if we've picked the classes effectively, that's true. Let's revisit this method that takes one integer input and produces a string output. What are appropriate equivalence classes for this situation? Let me let you think about that for a minute. Here's one possible answer to that question. 3 equivalence classes, 1 to cover the negative integers, 1 to cover 0, and 1 to cover the positive integers. Now you could argue that perhaps we need 2 other equivalence classes. Maybe we should divide the positives into the smaller positive numbers and larger positive numbers, and the same with negatives. That's a good argument. You could make that, and that might be a better testing strategy in this situation. But let's stick with these for now and ask the question, how do we use these to guide our testing? Well, we just pick one element from each of those. I happen to have picked -17, 0, and 121. Why those inputs? Remember, the principle is that all elements of those equivalence classes are equivalent, so we can just pick any one that we want. There was nothing special about the ones I chose. Now, is that all the testing we need to do? Probably not. Probably need to do more testing than that, but at least this will guide us in our testing. And it avoids some situations I've seen, particularly again with novice programmers, in which they tend to test, say, small positive numbers and forget about 0 and forget about negative numbers. So pause now and do the quiz, and then go on to part 2.